We are going to present our paper COVID-19 detection from chest X-ray images using deep learning techniques. You all are very much aware of the threat looming over us both globally and in the Indian context for the pandemic. Here are some figures that were accessed today. The motivation is to detect disease subjects from X-ray images as a preliminary check, as X-ray is very cheap and accessible to people. Our goal is similar to the motivation. We have always seen that there is a close association of deep learning with chest X-rays for disorder detection, and we tried out our model in regards of COVID-19 detection. We did the work before April 2020, and then extensive work for COVID-19 on chest X-rays weren't so much available, so ours was an innovative project. Our dataset had two categories. The disease samples contained 25 samples in number, and the healthy samples were also 25. The number is only 25 for the disease samples, as data with clinical correlation wasn't so much available at that time. Next, we come to our methodology. To detect a COVID-19 affected individual from his chest X-rays, we use a VGG16 network pre-trained on ImageNet. ImageNet is a dataset which has over 14 million images that can be classified to 1,000 different classes. In our study, we fine-tuned this model as per our training and constructed a fully connected layer of our own instead of using the VGG16's network. We have looked to fine-tune a convolutional neural network model using TensorFlow 2.0 and Keras deep learning libraries using TensorFlow.keras to automatically detect whether or not the person whose chest X-ray is in consideration is affected with coronavirus or not. For loading and preprocessing the images, scikit-learn, matplotlib, OpenCV, NumPy, and many others were considered. We initialized the hyperparameters, namely the initial learning rate, which was set at 0.001, number of training epochs were set to 25, and the batch size as 8. Then we had loaded the images and the preprocessing began. For each image path, we extracted the labels, that is, whether the concerned image was that of COVID-19 positive or of a healthy individual. The preprocessing of the data involved converting the images to RGB channel ordering, followed by resizing of the images so that it could be converted to 224 cross 224 pixels and make it prepared so as to be fed into the convolutional neural network. Next, we scaled the pixel intensities within 0 to 1 and converted the data and labels as obtained in the previous step to an array using NumPy library. We encoded our labels to create the split between the training and the testing data, 80% for training, 20% for testing. The encoded label was a two-element array of either 0 or 1, wherein 1 was for the COVID-19 positive subject and 0 for otherwise. We rotated the images by 15 degrees either clockwise or anti-clockwise to increase the dataset during data augmentation procedure. Next, we initialized our VGG model, which was pre-trained on ImageNet as we already discussed. Here we left off the fully connected layer. Instead, we constructed our own fully connected layer and added it on top of the VGG layer, or rather the VGG network. In the network, we used the Atom optimizer with the learning decay rate initialized as the ratio of initial learning rate to the number of epochs. We used the binary cross entropy and metric of accuracy in our model. We invoked the Keras fit generator procedure through the data augmentation object that we had instantiated earlier. Coming to the results, we obtained a very high precision, which meant that the model had that ability whenever it detected someone to be COVID positive, there is a good possibility that it would be clinically correlated to be positive as well. A high recall we obtained, which meant that the model had performed actually very well on the classification task. Similar was in the F1 score, which had a high F1 score meant we did a better classification. Next, you can see the training loss and accuracy of the model. The point to be noted was the accuracy was always above 90% after the 5th epoch. So we also had measured the sensitivity and specificity of the model. Sensitivity was 1, which was very satisfying, indicating the model's ability to identify true positives. Overall accuracy was 90%. Our model does not have the problem of overfitting despite the small training data that we fed into the model. Basically, if we can try other clinical metrics and correlate with them, preferably have a larger dataset to test upon, the model accuracy can be improved. Here are some of the references that we used to our benefit, and thank you for a patient hearing.